Hello everyone. So I gave you one question to think about boiling point, right? How many of you figured out what should be the definition of boiling point? Good evening everyone, good evening. So what should be the definition of boiling point? We were having this discussion, right? What is the boiling point? I told you this question, right? What is the boiling point? Good evening everyone, good evening. Voice is low as the class will, voice is low. Can we increase the voice? No, it's fine. Okay, so boiling point please. The definition should be boiling point. What is the boiling point? We were discussing in the last class, right? The state at which substance exists at two states, both liquid and gas. Liquid changes into phase, okay. Gas phase, okay. Transformation of liquid into gas, no. So if that is what the doubt were, right? That if you're having any temperature, in which liquid can be converted to gas, according to that logic, any given temperature, let us say 50 degrees Celsius, will also 50 degrees Celsius will also be considered as boiling point. As I told you, if you look into the open lake, right? So max temperature, how much could be achieved? The temperature at which its vapor pressure equal to the atmospheric pressure, causing it to the temperature from a liquid to gas. Very, very good. Very good, Jitendra Kumar. Very, very good. Yes, that is the actually correct definition. So he is talking about the pressure, right? Very good, Jitendra. Now, let me ask one more additional question, and then we will come to the atomic structure chapter, right? Okay. Now, let me have this question, one more problem for you. Let me say that, okay, let us say we are having 3 containers. Listen my question very, very carefully, very, very interesting question, and this will help you a lot in thermodynamics. In thermodynamics, we will discuss a concept which is known as entropy. And let me tell you, every student suffer with the concept of entropy, so it will become very difficult, right? So we'll come to that. Entropy, so this concept will help you a lot. Now listen carefully. So we are having liquid. Let us say we are having liquid into all 3 containers. What is the liquid? Water liquid. So I'm having water liquid in all the 3 containers. In all 3 containers, we are having water liquid, and some liquid has come to the vapor form. Some liquid has come to the vapor form. Let us say, okay, yellow, which color? White, okay. So let us say some of the liquid is present in the vapor form, right? And now what I am going to do is, I'll tell you one very, very important point. Always remember, throughout your 11th, 12th preparation, always remember that boiling point, melting point, these are the thermodynamic properties. Remember, right now you may not understand fully what is thermodynamics, but remember it is thermodynamic property. And in the case of thermodynamic properties, we always consider closed system. You know what is closed system? Closed system means it is not open container anymore. So I am going to put a piston over here. So I will put a piston, right? So let us say we are having a piston over here. I am putting a piston. Piston means something which can move up and down. So in the container, I have put a piston which can move up and down. It can go up and it can come down depending on the pressure. Now listen very carefully. Now my question is, let us say that temperature is equal to, for this particular container, middle one, let us say temperature is equal to 373.15 Kelvin, right? This is the temperature. And in all the conditions, what is the pressure we are living in? What is the pressure? What is the pressure? Tell me. What is the pressure of the surrounding? What is the pressure? What is the pressure of surrounding? No. 1 atm. Remember, if you don't know, very good. nerd, somebody is there, 1 atm, very good. 25 degrees Celsius, no. So 1 atm is the pressure, very good. So external pressure is 1 atm. So in every case, external pressure is 1 atm. For all the containers, external pressure is 1 atm. Now listen carefully. Now for the middle container, we are having temperature 373, and for this temperature, let me say that I'm having 500 Kelvin temperature. And let me say that for this one, I'm having 300 Kelvin temperature. So for the first container, 500 Kelvin, second container, 373.15, and for the third one, we are having 300 Kelvin. And in the container, I have kept a piston over here. External pressure is 1 atm. Now I'm going to define the boiling point. How to define the boiling point? Listen carefully. Now, all of you know what is equilibrium. Equilibrium means, let me give you one example to make you understand what is equilibrium. Okay, so let us say that I'm having a container, and this container is something like this, right? So this is having inflow of water, let us say inflow of water, and outflow of water, something like this. So there is outflow of water, inflow of water and outflow of water. Now, as you start to fill the container with the water, what will happen? Water, right? So initially it will start to fill, the container is filling. A point of time will come when the container is filled, right? Once the container will filled, what will happen? The water will move in and the water will move out. That means rate with what? I think all of you know what is rate, right? So rate of inflow of the water will be equal to rate of outflow, right? Rate of inflow is equal to rate of outflow. Now the amount of water has become constant. Amount is not changing anymore. Inflow water and outflow ka rate has become equal. This point is known as equilibrium. This point is known as equilibrium. Inflow and outflow rate same, known as equilibrium condition. Okay? All of you understood what is equilibrium? Just give us a thumbs up. All of you understood what is equilibrium? Just give me a thumbs up. Equilibrium, clear to everyone what is equilibrium? Okay, Divya, great. Okay, great. So we have come to the equilibrium point. Now, let me come to this one. Temperature 500 Kelvin, temperature 373.15, and temperature is equal to 300 Kelvin. Now, the nature of temperature is to be in equilibrium. What does it mean? Let us say we are having a container, and you divide the container into two equal half. Now, what you do is, in one we are having 25 degrees Celsius, in other one we are having 50 degrees Celsius. If you open the container and let the temperature flow, what will happen? Temperature will become constant, right? So higher temperature to lower temperature. Now temperature has come to equilibrium. Same goes for pressure. If you are having a big container and in the middle you are having a wall dividing this container. In one, let us say we are having 50 atm pressure. In one we are having, let us say, 25 atm pressure. Now what will happen? If I open the wall, what will happen? High pressure to low pressure. Again what will happen? Pressure will come into the equilibrium. Pressure has become constant. So this is the nature of pressure or temperature. They always want to achieve equilibrium. Now listen carefully. Inside, pressure we don't know right now. Outside pressure is 1 atm. Now what is boiling point? Now in this particular container, liquid evaporates into vapors. So some amount of liquid will convert into pressure. Now this is very interesting. This is the experimental observation we have seen, that if you are having a piston which can move up and down, right, and if you are having 373 temperature, what will happen is, or the liquid will start to convert into vapor, and inside the container pressure comes out to be 1 atm. Very, very interesting. Pressure of inside becomes 1 atm, and already pressure outside is 1 atm. Inside pressure 1 atm, outside pressure 1 atm. What will happen? Are we achieving equilibrium over here? Yes or no? External pressure 1, internal pressure 1. Piston will never move up, nor it will move down. Yes or no? Yes? Just say me yes. Have you understood? Great. All of you understood, right? So piston will neither move up nor it will move down. Great, right? Okay, so now this temperature at which this liquid, water liquid, is in equilibrium condition. This is the sign of equilibrium. This liquid is in equilibrium with gas. At what temperature? 373. Or I can say that internal pressure is equal to external pressure. Internal pressure equal to external pressure, or liquid is in equilibrium with gas. Right? Now, the piston neither move up nor move down. Liquid goes to vapor, vapor particles come to liquid. Liquid goes to vapor, vapors come to liquid. This is the condition of equilibrium, and this temperature is known as boiling point. So you can never define the boiling point for open atmosphere. If you are having a lake and if that water is present and you let the water convert into vapor, it can happen at any temperature, but that is not the boiling point. Boiling point, this is very, very important. This is very useful for thermodynamics. You'll get to see. So we always define thermodynamic properties for closed system. System should be closed. It should not be open. Now my question is, for condition 1 and condition 3, in the first condition, we are having liquid, or we are having gas, or we are having both. In the first condition at 500 Kelvin, we will have liquid, gas, or both. First condition. And for the third condition, same question. We are having liquid, gas, or both. In second condition, we are having both liquid as well as gas. Both are in equilibrium. Tell me about the first one. What will happen at 500 Kelvin? Liquid, gas, or both? First condition, please. Liquid, gas, or both? First one. Gas. Very, very good. First condition, gas. Very, very good. Yes, great. Gas. Yes. Now what is happening? Very, very important. Now, the pressure of inside, let us say we are having high temperature. If you have high temperature, what will happen? Internal pressure will be more than 1. Why it will be more than 1? Because at 373, the pressure is 1. So more than 373, pressure will be more than 1. Let us say this pressure is 1.2 atm. Right? Now, internal pressure more, external pressure less. What will happen? Piston move up. As piston move up, again the pressure will become 1. Right? Now again, because the temperature is more than 373, again more liquid will come to vapor. Again pressure becomes more than 1. Again pressure more than 1. Again piston moves up. Again pressure is in equilibrium. I hope you are getting my point. Right? Now again what will happen? Again temperature is more. More liquid will come to vapor. Again piston move up. So this will continue till all the liquids has converted into vapor. So in the first one, we are having only gas. In the second one, what will happen? Because the temperature is less than 373, what will happen is internal pressure will be less than 1 atm. Internal pressure will be less than 1 atm. Yes or no? In that case, what will happen? Because internal pressure is less than 1 atm and external pressure is more, piston moves down. As piston moves down, it will push the gaseous particles into liquid state. Gas particle comes into liquid. Now again, pressure will increase. 1 atm, again it will become 1 atm. Because piston is moving down. Again pressure is in equilibrium. Right? Now, because particles has converted into liquid, again pressure will fall down. Again internal pressure is less, external pressure more. Again piston moves down. Are you getting my point? Yes or no? Both liquid and gas at 3, how is it possible? Venkat, both liquid and gas, how is it possible? Liquid, right? Again, so because internal pressure is less, piston moves down, pressure becomes equal. Again, because of low temperature, pressure decreases. Again, external pressure more, internal pressure less. Piston moves down. So this process will continue until this piston has come over here. Until this piston has moved over here. That means all the gases have been converted into liquid. Right? So this is the definition. This is the definition of boiling point. What is the definition of boiling point? How can we define boiling point? Tell me. Boiling point is that temperature Boiling point is that temperature. Boiling point is that temperature at which liquid and gas exist in equilibrium. This is definition number 1. This is very, very important for you guys. Is that temperature at which liquid and gas are in equilibrium. Definition number 2. What will be definition number 2? This is first one. Second definition will be temperature at which internal pressure becomes equal to external pressure. Now let me ask you one question. Let us say if I increase the external pressure, right now for us external pressure is 1 atm. If I make the external pressure 2 atm, will the boiling point of water will be 100 degrees Celsius or more than 100 degrees Celsius? Let me know. Let me know, please tell me. More than 100 degrees Celsius or less than 100 degrees Celsius? More than 100 degrees Celsius. Very, very good. More than 100 degrees Celsius. Because once the external pressure is more than 2 atm, you need more temperature, right? Yes. So therefore, whenever we define boiling point, boiling point will be always defined not only with temperature but along with the pressure. So whenever you define boiling point, you don't say only about temperature. Pressure should be also, told. External pressure, if it is 1 atm, then the boiling point of water is 100 degrees Celsius. Am I clear to everyone? Yes, just give me a thumbs up. Am I clear with the boiling point? Yeah, I'll explain the equilibrium once more. Yeah, I'll explain the rate and equilibrium. Just give me a thumbs up. Is it clear to everyone? Boiling point? Okay, great. This is very, very important. Please remember, this will be used in thermodynamics, guys. Very, very important concept. Without this, you won't understand entropy. And remember one thing, thermodynamics is always studied. Remember, thermodynamics is always studied for open system or closed system. Thermodynamics is always studied for closed system or open system. Thermodynamics, boiling point, freezing point, melting point is only defined for open system or closed system. Entropy will study beta ji later. Closed system, very, very good. It should be always closed system. System should be closed. So thermodynamics, it's studied for closed system. Please remember this. Some of you are having doubt with the equilibrium. I'll just repeat. Just look at this. Let us say that. Okay. So this we are having inflow. This we are having inflow of water. So water is flowing, inflow. And what will happen initially? The container will fill. Container fills, container continues the process, filling of container. A point will come where what will happen? Overflow will start to take place. So we have an outflow, right? Now once the container is fully filled, water will flow in and water flows out. Rate will remain same or it will be different? For inflow and outflow, rate will be same or different? Same or different? Just give me the answer. Rate and speed, you have not studied speed in your high schools. Same, right? Yes. Rate of inflow and rate of outflow will be same. That is the condition of equilibrium. That is the condition of equilibrium when inflow ka rate is equal to outflow ka rate. Right? Inflow ka rate is equal to outflow ka rate. And what will be the amount of water? It will be constant or it will change? Amount of water, just say me, constant or changed? Amount of water, constant or changing? Amount of water will remain constant or changed? Constant, right? Okay, very good. Now, we are starting with a new topic now, starting with the atomic structure. Everybody excited for the atomic structure? Let us start with the atomic structure. flow of water per unit time. What is rate? In this particular case, flow of water per unit time is rate. Okay, chalo, we are starting with the atomic structure now, right? So let me go with the atomic structure. We are starting with a new chapter which is called as atomic structure, right? Now, let me introduce you. See, many of you will study atomic structure, emission spectra, absorption spectra, black body spectrum, this and that. Very difficult points you guys will study, right? Very, very difficult point. But my question is, see, this is very, very important. Whenever you start a chapter, you should always know what is the purpose of the chapter. So what we are trying to study in atomic structure? What we are trying to study in atomic structure? You know, very, very simple thing. You look at the name of the chapter. Name of the chapter suggests that we are going to study structure of atom. What we are going to study in atomic structure? Structure of atom, right? Now, how to study the structure of atom? Now, different models came. Different model came, right? Different model came to explain the structure of atom. Few very basic models you have already studied. What are few basic models? Few very basic models were, one is plum pudding model. All of you have studied plum pudding model, right? Now, let me come. Why do we need structure of atom? Why it is needed? Why the scientists started to think about structure of atom? Why? We'll come to that question. Why it is needed? Now, initially what happened is, with the help of J.J. Thomson, what happened? Discovery of electron. If I am not correct, approximately 1897, I don't remember exactly the year, but discovery of electron took place, right? And after the discovery of electron, there is something called as proton. Proton ka discovery took place, right? So in the Dalton atomic theory, we'll come to Dalton atomic theory. In Dalton atomic theory, Dalton is only talking about conservation of atom. What is the major point of Dalton atomic theory in high school? What you have studied? The most important aspect of Dalton atomic theory is atoms cannot be destroyed, right? In a chemical reaction, what will happen? For example, if you have H2, one element, and if you have O2, they react with each other and they will form water, right? Now, is any atom destroyed over here? No, no atom has been destroyed. What has happened is, one atom combined with other atom to form a compound. So this is nothing but reorganization of atom. This is very, very important point. So Dalton theory says that, this is the most important point of Dalton ka theory. Dalton says that atoms can neither be created nor be destroyed. So what happened in a chemical reaction? Are atoms going to be destroyed? No. Atoms ka reorganization will happen. You see, hydrogen over here, oxygen over here. They have been reorganized in a certain manner so that they have been converted into a compound. This is the major focus of the Dalton theory. And Dalton theory explains few more laws. Law of definite proportion and law of multiple proportion. We'll come to that. Before that, let me tell you. So Dalton ka theory, first theory of Dalton, says about the reorganization of atom. But it is not saying anything about the atom. How atom look like? Dalton has no idea how the atom looks like. It gives you some information about chemical reactions which are happening, some reaction which is happening, how the reaction will happen, what is conservation of mass. It is giving all those information. Conservation of mass, right? But we'll come to those things. But it is not giving any information about structure of atom. No idea about structure of atom. Therefore, why he has no idea about the structure of atom? Because by that point of time, there was no discovery of electron, proton or neutron. Once discovery of electron, proton and neutron took place, all of you know J.J. Thomson electron, proton ka discovery took place, and Chadwick gave the neutron. So once there was discovery of electron, proton and neutron, once the discovery of electron, proton and neutron took place, which are called as the fundamental particles. Fundamental particles of atom, also known as subatomic particles. fundamental particles of atom, also known as subatomic particle, which is electron, proton and neutron. I'll discuss more about them. So once the discovery of electron, proton, neutron took place, people started to think how to arrange them, how they are because electron is negatively charged and proton is positively charged, so how they are arranged in an atom, how the atomic model should be. So people started to think. So first model came, which is known as plum pudding model. What is the plum pudding model? In the plum pudding model, watermelon model, which we say, right, what is happening in that? There are seeds into the model, watermelon. So those seeds are acting like electron and the remaining mass is called as proton. So plum pudding model says only one thing. What it says? It says something about electrical neutrality. There is electron, there is proton, they are electrically neutral. But it says nothing about what? Hydrogen spectrum. Why somebody shows a spectrum? Why there is color with the atom? Why some atoms are colorful? Why some atoms are not colorful? It has no information to all those questions. And it really doesn't give any depth about the atom, right? So the new model came, which is called as Rutherford model of atom. So I'll discuss Rutherford model of atom and then I'll explain you what is atomic number, what is mass number, and all these aspects will come to that. So let me introduce you the Rutherford model and how come discovery of nucleus took place. So I'll repeat once again. Plum pudding model doesn't give any depth about the structure of atom. How electron, proton and neutrons are placed, we have no idea how they are placed in an atom. Rutherford model was one genius scientist who gave some picture about the atom. Let us come to the Rutherford model then. Let's see. So in Rutherford model, Rutherford performed an experiment. What is that experiment? Experiment was, there is a gold foil. He took a gold foil which is very, very thin, of the micrometer size. Very, very thin gold foil. He put the gold foil and around the gold foil he placed a zinc sulfide screen. What he placed? Zinc sulfide screen. Now zinc sulfide screen has the property of fluorescence. We are not going into that. Simply remember, if the particles will strike zinc sulfide screen, there will be spots, color will appear, spots will appear. That is how we will know, okay, the particles have passed through the foil. Great, let us start. What will happen? Okay, so now we are having thin foil. Now we are going to pass alpha particles. So this is the source of alpha particle. This is the source of alpha particle. Source of alpha particle. So this source of alpha particle is going to bombard alpha particles. So alpha particles are being bombarded, right? Alpha particles are being bombarded toward the gold foil. Now observation is very unique, observation is very unique. What do you imagine? If you are throwing gold, alpha particles, which are assumed to be positively charged, right? So if you throw the particle, atom contains positive charge, proton and neutron, right? So what should happen is that this positive charge alpha particle should strike with positive charge of the atom, gold, which is gold atom, and what should happen? Some scattering should happen, right? Or deflection should happen. So this should be deflected like this, this should be deflected like this, or sometimes deflected back also. Sometimes it might be deflected back also, right? Yes or no? It could be deflected back also. But we are not seeing anything like that. The observation was most of the particles pass undeflected. Nothing is happening to the particle. No interaction whatsoever. Most of the particles are passing through the gold foil. Right? Now let me represent like this. All the particles are passing through. No deflection, no deflection, no deflection at all. That means we are not observing anything over here to this end. We are nothing observing to this end. Everything is passing by. What is happening into that? What is happening, guys? If no interaction is happening, no deflection is happening, no scattering is happening, what is happening? What do you think? Only one particle deflects back on surface. We will come to that. What is happening? What it suggests? If no scattering is happening, no deflection is happening, what it suggests? it suggests that atom is almost empty. There is nothing in the atom. If you look at the broader picture, what it suggests, there is no space in that. I mean, atom is empty. There is only space. But one very interesting observation we had, that among 8,000 particles, how many particles among? 8,000 particles, one particle reflected back. So I am denoting by this red color, right? So one particle deflects back. Among how much? 8,000. In 8,000, only one particle deflects back by 180 degrees. 180 degrees. And few particles deflected through certain angles. Through certain angles, few particles. 1 in 8,000, 180 degree. 1 in 8,000, 180 degrees. Most of them will pass undeflected. It suggests that, what it suggests, the space of the atom is empty, right? There is no occupation, nothing is occupied. Only there is something which is inside the atom, which is of very, very small size. When the alpha particle strikes to that, suddenly it reflects back. So what is that called as? So Rutherford gave that name. He said that it is nucleus. So Rutherford was the responsible person for the discovery of the nucleus. He suggested that because the alpha particle is positively charged and it strikes to the nucleus, it will deflect back 180 degrees. And because the nucleus size is very, very small, imagine like this, a very small size, and there is a big atom, in the big atom, very small size nucleus. So if alpha particle goes like this, so many particles are coming, so many particles, atom is empty space. One particle strike back, few particles deflect at certain angle, because positive charge, repulsion will take place, right? But most of the space of the atom is empty. Great, great. So he gave this name of nucleus. He said that, what is the size he said? He says that if the atom, it has been derived mathematically, that atom ka size is approximately, 10 to the power minus 10, and nucleus ka size is 10 to the power minus 15. You can imagine the difference in the size. 10 to the power minus 10 is the size of the nucleus, atom, and 10 to the power minus 15 is the size of the nucleus. So you can imagine 10 to the power 5 times, 10 to the power 5 times bigger is the size of the atom in comparison to the nucleus. You can imagine it is in such a way, let us say that, you are sitting in a, let us say everybody is talking about RCB and this and that. Let us say that you are, in the stadium, right? You have went to watch Virat Kohli playing, right? So now, if you look at the whole stadium, let us say that is the size of the atom, and you see a small cricket ball, that is the size of the nucleus, approximately I'm saying. So you can imagine the space, the whole atom is actually empty space, right? And there is a small size particle which is the nucleus. Meters, unit is meter. Right? So that is the kind of size of the nucleus, and atom size is. How big an atom is and how big, how small the nucleus is. Basically it is being said that if you understand one atom, you can understand the whole cosmos. Why is that? Because what is cosmos? Most of the space of the cosmos is empty. Most of the space of the cosmos is empty. Occupied is how much? Let us say we are coming to the atom, definition of atom, and few fundamental definition which is needed. Okay, so let me define what is charge, what is atomic number, what is mass number. Let me define a few of them. Okay, let me come to this. Okay, so let us talk about the fundamental particles. If we talk about the fundamental particles, we are having electron, proton, and neutron. So these are the fundamental particles we are having of atom, electron, proton, and neutron. We'll look at their charge. What is the charge? Absolute charge. Absolute charge means their value. What is the charge of electron, proton, and neutron? Absolute charge, values. What will be values? 1.6 Please remember, what is the SI unit? What is the SI unit of electron? What is the SI unit of electron? Coulomb. Please remember. Coulomb is the SI unit of charge. Right. So, 1.6 into 10 to the power minus 19 Coulomb is the charge of electron in negatives, right? Negatively charged. And charge on proton is 1.6 into 10 to the power minus 19 Coulomb. And neutron supposed to be neutral, so no charge. So this is absolute charge value. What will be the relative charge? If I'll ask you, what is the relative charge? What will be relative charge? Let me know. So this is what we are going to use. This is called as formal charge. You'll come to know about this. So relative charge is -1. Generally we assume electron -1 charge. We'll come to that. -1, proton +1, and this will be 0. So this is the relative charge we are having. Okay. Now, what is the mass? So again, we'll come to know absolute mass and relative mass. We'll come to know absolute mass and relative mass. I don't remember the exact value. It is a big number. If you want me, I can write, but actually I don't remember exact. So I'll write the approx values. So this is electron. Electron ka mass is least. How much it is? So this is 9.1. There is a value 9.16, something like that. So 9.1 into 10 to the power minus 31 kgs. And what is the mass of proton? It is 1.67 into 10 to the power minus 27 kgs. And what is the mass of neutron? It is slightly more than 1.67, the value. I don't remember exact values. You can look into the NCERT textbook. The exact values are given in the atomic structure chapter. So it is 1.67 into 10 to the power minus 27 kgs. Right. So now let me tell you, this question is very, very prominent. So many times it has been asked, which is the heaviest among electron, proton and neutron? So it's very easy to say that mass of electron will be least, right? Mass of electron will be least. Then what will come? I don't remember the exact value. It is a big number. So you can look into the NCERT textbook. So but the mass of neutron is maximum. And this is very, very useful in which chapter? Nuclear physics. You see nuclear energy, delta. There is something called as mass defect. Please remember, don't forget, write in your notebooks. Mass defect ka concept will come with this small difference of mass which is between mass of neutron and proton. Right? So please remember. So mass of proton and the maximum mass is of neutron. Please remember this. So maximum mass belongs to neutron, then mass of proton, then mass of electron. And there is a very, very interesting question which has been asked so many times. What is the ratio of mass of neutron and mass of proton? What is the ratio? This question is very, very famous. So if you write the exact values, you will get it is 1837. What is the ratio between mass of neutron and mass of proton? 1837. That means mass of neutron is 1837 times of mass of proton. Please remember this. And let me tell you, 1857 nahi beta ji, 1837, not 57. And let me tell you, it's very, very interesting. 1837 is the year in which Newland was born. You know what? Who is Newland? Newland was a chemist who gave the introduction about the periodic table. We'll study something called as Newland law of octaves, right? Absolute and relative means this is the absolute value. This is the absolute value. Relative means how much, what is the relation? This is, if you consider this to be 1, so this is -1, same value, so +1. So that is relative, right? Okay, so mass of neutron, mass of proton, mass of electron, this is very, very important. Please remember this. And the ratio between mass of neutron and mass of proton is 1837. Okay. Derive it. What to derive? Yes, Newland law of octave. Yes, Newland law of octave, you will get it, right? Okay. So, so this was basic introduction about the fundamental particle. Using these electron, proton and neutron, we are going to define what is called as atomic number and what is called as mass number. Let us come to that. Okay, so atomic number. Okay, so from Rutherford model, we have the discovery of nucleus, right? So Rutherford model, what suggested? Let us look at the picture of Rutherford model. Now after the discovery of nucleus, Rutherford says that there is a small size nucleus, and around the nucleus, electrons are orbiting like a planetary model. Planetary model, all of you know planetary model, right? There is sun around which the planets are revolving, right? Planets are revolving around the sun. The same model Rutherford copied, and he said that, what he said? That electrons are like revolving in the orbits, like how the planets revolve. And in between there is something called as nucleus, like sun. He gave this model because he discovered that most of the space is empty. So nucleus should be of very small size, right? So it is in the center and there are electrons revolving in the orbit. But there were drawbacks. There were drawbacks in Rutherford model. What are the drawback? You know, I don't have much time, otherwise we won't be able to explain atomic number and this and that. But the drawback was, you know, if let us say we are having a charge. If charge is static, right, it is not moving, it produces electric field. Just remember, you will study all this in 11th and 12th class. If there is a static charge, it will produce electric field. If there is a moving charge with uniform velocity, remember, uniform velocity, it will produce magnetic field. And if there is a charge which is moving with accelerated motion, it will produce electromagnetic field. We'll discuss electromagnetism little bit, not much in detail, study in 11th class. So, to do that, you will need to be online. So you have, once you have the electric charge which is accelerated, you will study in 11th and 12th class that Maxwell says that if there is a charge, accelerated charge, it will lose energy. You will study this. So once it loses energy, what will happen? Because the electron is losing energy, it will do a spiral motion, and it will collapse into the nucleus. So atom is not stable. So this was the failure of Rutherford model. Rutherford model gave a very good idea, but he could not explain the stability of atom. He explained neutrality, negative and positive, but he could not explain the stability because, as I said, Maxwell, according to the Maxwell theory, if there is a charge and it is doing the motion with accelerated motion, it will lose energy, and mathematical derivation has been done. It takes 10 to the power minus 8 seconds to collapse into the nucleus. Then comes Bohr model. Right now we are not having the time for Bohr model. You will come to know in 11th class, very beautiful model. So in the Bohr model, it has been explained properly that this is the simple structure of atom. I'll come to the next page now. So the simple structure of atom is, there is nucleus and electrons are revolving. They are revolving in certain orbits which are called as stationary. That means electrons will not lose energy. That is the beauty. These are the assumptions you will come to know in 11th class. We are not going into that. Quantum model will come later, right? Okay. So this is the simple structure of atom. This is the simple structure of atom. Electrons are revolving around the nucleus. Great. Electrons are revolving around the nucleus. Happy birthday. How do you know my birthday? Okay, so electrons are revolving around the nucleus. Now we are going to define atomic number. Atomic number का concept was given by a scientist known as Moseley. So Moseley performed an experiment. You study this experiment in physics. Moseley performed an experiment between frequency. I'll not go into that. Actually, it will waste our time. We'll study in 12th class. So Moseley gave the idea of atomic number. So what is atomic number? Atomic number is equal to number of electron also equal to number of proton in which state? Neutral state. Please remember, not always, only in neutral state number of electron will be equal to number of proton. Please remember, right? Number of electron, number of proton only in neutral state. Or if it is charged, will come why it is charged. If it is charged, you always remember, don't think about number of electron. Atomic number means nothing, number of proton. This is always true. Number of proton is always true. Number of electron will change if it is in charged state. In neutral state, atomic number is equal to number of electron, which is equal to number of proton. Great. So this is atomic number. Let me take few examples of atomic number. and we'll see something. Let us say we are having sodium. How do we represent any atom? So atom ka symbol is Z, right? Atomic number symbol is Z. Atomic number symbol is Z. How do we represent an element? So X, we are writing an element, and mass number ka symbol is A, so that you can understand. We'll come to mass number. So this is represented as Z and A. So this is the representation of atom. This is the representation of atom. How do you represent an atom? So X is the element, Z is the atomic number, A is the mass number. Let me write few elements for you. Let us say that I am writing sodium. So what we'll write is sodium ka atomic number 11 and mass number 23. Now you please remember the atomic numbers from 1 to 40, very, very important. 1 to 40 you need to memorize from periodic table. Please have the periodic table, memorize the values of atomic number 1 to 40. Let me take few more examples. Let us say oxygen. So how would you represent oxygen atom? Oxygen. Left side we will write atomic number. What is that? 8. And what is the mass number? 16. Atomic number 8, mass number 16, right? Similarly, if you have to write nitrogen atom, how would we write? Nitrogen atomic number 7, mass number 14. Now we have understood what is atomic number. What is atomic number? Number of proton. Always remember. Forget about electron. Electron is only in neutral state. Atomic number is equal to number of proton. Okay, now what is mass number? Let us come to the mass number. Mass number, which has a symbol of A, is equal to number of proton plus number of neutron, right? Number of neutron. So neutron was discovered later, and it was assumed that, let me draw the model again, structure. So inside the nucleus, there is proton and neutron, and electron is orbiting. So there is proton and neutron inside the nucleus, right? So what is mass number? Mass number is nothing but number of nucleons. What is mass number? Number of nucleons. What is nucleons? Anything which is present inside the nucleus. That is number of proton plus number of neutron. Okay, is it clear to everyone? Number of proton? Yes. So if I'll ask you, let us say we know that calcium ka mass number, how we write calcium? Calcium ka atomic number 20 and mass number 40. So according to the formula, A is equal to number of proton and number of neutron. Number of neutron, right? Now, what is the atomic number? Number of proton, right? Atomic number is number of proton. What is that? 20. And what is the mass number of calcium? 40. And then what we can calculate is the number of neutron. So what is the number of neutron in calcium is equal to 20. Let me take one more example. Okay. So let me say that we are having which atom? Carbon. Let us say carbon, how we represent 6 and 12. So 6 represents atomic number and 12 represents mass number. Can we calculate the number of neutron? Yes. What is mass number? A is equal to number of proton plus number of neutron, right? What is number of proton? Number of proton is 6. What is mass number? 12. We don't know what is number of neutron. So what is the number of neutron then? It is equal to 6, right? So I think all of you understood how to calculate atomic number. Atomic number will be given, so that is equal to number of proton. What is number of neutron? Number of neutrons is equal to mass number minus atomic number. How do we calculate neutron? Mass number minus atomic number. Is it clear to everyone? Just give us a thumbs up. Is it clear to everyone? Atomic number, mass number, proton, neutron. Is it clear to everyone? Just give us a thumbs up. Everyone please, quickly. Just give us a thumbs up, everyone please. All of you understood? Okay, great. Okay. Great. Now, let us define few important terms which we are going to use. So we have defined atomic number, mass number. With the help of atomic number and mass number, we are going to define something called as, what is isotope, what is isobar, what is isotones, what are isodiaphers. We are going to define these stuff. Okay. How to find mass number, please? Mass number will be given to us. And once you know the atom, atomic number and mass number will be known. That we have to remember from the periodic table. Our time is up. I'll just take 2 minutes. I'll explain the isotope and remaining parts will continue in the next class. Right? Yes, time is up. Okay, just 2 more minutes. What is isotope? Can anybody define isotope for me? Isotope, please. What is isotope? Anyone, please. What is isotope? Yes, it not necessary in the papers mass numbers are given, but it is good that you remember from atomic number 1 to 20. Same atomic number, different mass number. Very good. So isotope is same atomic number and different mass number. Same atomic number, different mass number, known as isotope. We'll take few examples. Yes, we'll take few examples. For, let us say we are having hydrogen atom. So hydrogen has 3 isotopes. What are those isotopes? Isotopes will write like this. Atomic number same means 1H. Atomic number same 1H. Atomic number same 1H. What is going to differ is the mass number. So what is the mass number? Mass number 1H1, 1H2, 1H3. That means this is called as protium. 1H1 is known as protium, which is having atomic number 1 as well as mass number 1. This is known as deuterium and this is known as tritium. The symbols are protium, deuterium ka symbol D and tritium ka symbol T. Protium is simply written as hydrogen. Now, I'll ask one question and I'll finish the class. We'll come to oxidation state, we'll come to everything. Just tell me one thing. What is the difference in isotopes? What is actually differing? Proton is different, electron is different, or neutron is different? What is different? Now, see, very interestingly, if you have in an atom electron, proton and neutron, right? In an atom, if we are having electron, proton and neutron, then why come mass number is neutron plus proton? Why we are not adding electron then? Why we are missing electron? If the mass number is neutron plus proton, why it is not electron? What is the problem with the electron? Because we just now saw that electron ka mass is very, very small. Proton and neutron were of order 10 to the power minus 27 kgs and this is 10 to the power minus 31 kg. So mass of electron is approximately negligible in comparison to the mass of proton and neutron. Therefore, in the mass number, we only include neutron and proton. Now my question was, in the case of isotope, what is different? Difference, आइए check करते हैं. Let us check the difference. We'll come to this. So we are having 1H1, 1H2 and 1H3. Let me write everything. So what is atomic number? Which is number of what? Proton. Sorry, Z. Symbol is Z. So what is atomic number? I'll finish the class with this thing only. So atomic number Z, which is nothing but number of proton. What is the number of proton? Atomic number 1, 1 and 1. What is the mass number given to us? Mass number. What is the mass number? 1, 2 and 3, right? Now, what is the formula of mass number? A is equal to number of proton plus number of neutron. So what is difference in all these things? Atomic number same. So what is difference? I can write N is equal to what? A minus proton, which is atomic number. This P is nothing but what? Z, right? Atomic number. So N is equal to A minus Z. Let me calculate N value. Atomic number 1 and mass number 1. So N value is 0. Number of neutrons 0. Mass number 2, atomic number 1, N value 1. Mass number 3, atomic number 1, and value 2. So what is different in isotope actually? Number of neutrons. So neutrons are different in isotopes. Neutrons are different in isotopes, right? Neutron is different. Very, very good. Neutrons are different. Now my question to you guys is, with this, finishing the class. For isotopes, physical property and chemical property, will they be same or different? We have started physical and chemical property. I'm ending the class. So in isotopes, what about physical and chemical properties? Will they be same or they will be different? That is my question. We'll start from here tomorrow. For isotopes, chemical and physical properties, which property will be same and which property will be different? Chemical property will be same or different, and physical property will be same or different. We'll start from here. Thank you so much. We'll continue with the same question tomorrow, and we'll discuss other like isobars and isotones like that. Thank you so much, guys. Thank you.